Hello friends, today we are going to solve problem on SFD and BMD. The condition for SFD and BMD, or you can say the type, that is cantilever type. You can see the problem. Draw shear force and bending moment diagram for the cantilever shown in figure. You can see this diagram. The cantilever beam is given at point A. You can see A point is fixed. At B point, 3 kilonewton is acting. The distance is 1 meter from A. From B to C, there is no any force. The distance is 1.5 meter. From C point to D point, uniformly distributed load is given. You can see the intensity is given, that is 1 kilonewton per meter. The distance is 2 meter. D to E, there is no any force. At point E, vertically downward force is given, that is 2.5 kilonewton. You have to draw shear force and bending moment diagram for the cantilever. This is the cantilever case. You know that in the cantilever, one end is fixed, another end is free. If fixed support is there, then there will be a 3 reaction. There's 2 reaction and 1 movement. This one is your vertical reaction, that is VA. One more reaction, that will be the horizontal reaction, that is VH, and movement will be there. You can see this 3 body diagram. At point B, the 3 kilonewton is given. C to D, 1 kilonewton per meter. You can see here, C to D. At point E, 2.5 kilonewton is acting. By using our regular process, we have to calculate support reactions. By applying condition of equilibrium, you can find out VA, that is unknown, and MA, that is movement. You can see this movement, that is MA. So by using support reaction, summation of Fy is equal to 0. You can see VA is acting vertically, moving towards upward direction. So plus VA minus, at point B, 3 kilonewton is acting. So minus 3 minus, from C to D, there is a 1 kilonewton per meter. UDL is given. You have to convert into equivalent point load. It is 1 into 2. So minus 1 into 2 minus, at point E, 2.5 kilonewton is acting vertically downward. So minus 2.5 is equal to 0. This is the first case. So VA is equal to 7.5 kilonewton. There is only one unknown, so you will get the value 7.5 kilonewton. Now another case, summation of moment at point A is equal to 0. Here MA, we assume it is anti-clockwise. We are taking clockwise as a positive. So you can see here minus MA clockwise for 3 kilonewton. 3 kilonewton is moving in the clockwise direction. So plus 3 into perpendicular distance. Here the load is acting here, that is 2 kilonewton. Means 1 into 2, that's why it's a 2. So 2 is also moving in clockwise direction. So plus 2 into distance 1 plus 1.5, that is 2.5, plus 2 by 2, that is 1. So here 3.5. So 2 into 1 into 3.5, you can see here. 1 into 2, that is intensity. 2 by 2 plus 2.5. Plus this 2.5 is moving in clockwise direction. So 2.5 into this distance, 1 plus 1.5, that is 2.5, plus 2, that is 1 plus 1.5, that is 2.5, plus 2, that is 4.5, plus 0.5, that is 5. So 2.5 into 5 is equal to 0. Here in this equation, there is only one unknown, that is MA. So the value of MA will be 22.5 kilonewton. The value is positive. So the assumed direction is right direction. So MA is equal to 22.5 kilonewton into meter. Moment always in Newton into meter, or you can say the kilonewton into meter. By using a regular process, you have to calculate shear forces. Shear force at point A just to the left, just to the right. At point B just to the left, just to the right. Here do the necessary correction. B at point just to the right. Similarly for C, just to the left, just to the right. At point F, just to the left, just to the right. At point E, just to the left and just to the right. See, here by using our regular process, we have the value of VA. So at point A, just to the left, there is no any force at left side. So first answer is 0. A just to the right, you can see here, VA is moving upward. So plus VA, it is 7.5 kilonewton. At point B, just to the left, there is only one force, that is 7.5. B just to the right, you can see VA minus 3, you will get the answer at B, just to the right. C just to the left, the answer will be same. C just to the right, there is no any forces acting on C, so again answer will be same. But whenever you will consider D just to the left, plus VA minus 3 kilonewton minus 2, you will get the answer at point D, just to the left. D just to the right. At point D, there is no any force, so the answer will be same. From D to E, there is no any force, so shear force at point E just to the left, the answer will be same. E just to the right. Now in this case, VA minus 3 minus 2 minus 2.5. Definitely the answer will be 0. You can check this. Accordingly, you can calculate shear force at point A, at point B, at point C, at point D, at point E. Here you will get all the values for shear forces. Now the next, bending moment calculation. It is very, very important. Bending moment calculation. Similarly, bending moment at point A just to the left, bending moment at point A just to the right, at point B, at point C, at point D, and at point E. A just to the left will be 0. Bending moment at point A just to the right will be MA, that is minus 22.5 kilonewton into meter. See, bending moment at point B here. Every time you have to take that moment, this moment, it is minus 22.5. So minus 22.5 into VA into 1. But VA will move in the sagging condition. So plus VA into 1. You can see here. Plus VA into 1. Answer will be minus 15. Similarly, see, while taking this moment, while considering this moment, not need to multiply by distance. Again for C, the condition will be same. Moment at point C minus MA plus VA into 2.5 minus 3 into 1.5, you will get moment at point C. See here, you will get bending moment at point C. Now bending moment at point D here. At left there is only one force, you can consider left, right. At right there is only one force, you can take a right side, that is 2.5 into 0.5. That is minus 1.25. You can consider right side also, you will get the same answer. And bending moment at point E will be 0, that is end point. You can calculate, definitely the answer will be 0. See shear force diagram, as we know, plus sign is there, and in this condition, first that is minus 22.5, minus 15, minus 8.25, minus 1.25, and at point E that is 0. So it indicates negative sign. See, this is the problem for cantilever condition. All the steps are same, only change there is, due to this fixed end, there will be a one vertical, one horizontal, and one moment. Remaining things are same. This is the problem for cantilever condition. Remaining concepts are same. First of all, you have to calculate support reactions, then shear force calculation, and then bending moment calculation. At point A, additional moment is there, so you have to consider just to the left, just to the right. If additional moment is not there, then not need to take just to the left and just to the right while calculating bending moment calculations. The remaining things are same like previous. Thank you very much.